Okay, today we're doing negative and zero exponents. So let's start by developing like the pattern and seeing why the negative exponents work as they do. So if we look here, right, we know 2 to the first is 2, 2 to the second is 4, 2 to the third is 8, 2 to the fourth is 16, 2 to the fifth is 32. Right? So if we're looking to get to the next level, right, we're timesing by 2. We're timesing by our base. So what we want to do is we want to figure out what happens when we go down, right? When we have exponents that are zero, like 0 or less, right? So we have 2 to the 0, 2 to the 1, no, negative 1, 2 to the negative 2, 2 to the negative 3. Right? So let's figure out the pattern, right? When we're going down, we're dividing by 2, right? 32 divided by 2 is 16, divided by 2, divided by 2, divided by 2. So if we do 2 divided by 2, that would give us 1. And then if we divide by 2 again, 1 divided by 2 is 1/2. And if we keep going, right, we have 1/4 and 1/8. So something to notice with these is that you can also rewrite this. You can rewrite this as 1 over 2 to the 1, 1 over 2 squared, 1 over 2 to the third. So if you notice, our negative exponents are actually, we just put them in the denominator of a fraction. And that's how the pattern works. Something to note is 0 power always equals 1. So for example, 4 to the 0 equals 1, 9 to the 0 equals 1, negative 327 to the 0 equals 1. Even like anything, right, like star to the 0 equals 1. So this one's easy, but sometimes you'll forget and you'll get tripped up. And then when we have our negative exponents, right, negative exponents move that base and power to the other side of the fraction bar. Right, so the negative exponent rule is a vocab word, but we're going to put it into play here. Okay, so here are the problems, some example problems. So rewrite using positive exponents. So we have 2 to the negative 3, x to the negative 5, 3 to the negative 2, and 2y to the negative 4. Okay, so you can pause the video and try these, or you could do them along with me. So for this one, right now this is in the numerator, right? This is this over 1. But we see it's a negative exponent, so we have to switch it. So we're going to do 2 to the 3. And then what's left on top is just 1. You're not like necessarily flipping it, but it's sort of like you still have a fraction. So we need to have the 1 on top. And you can rewrite this as 1 over 8. So if you have a calculator, you can put this in to double check. You need to be able to do this without a calculator, but it's a good way to always see like if you're doing it correctly. Right? So I have right here 2 to the power of negative 3. Oops. 3. 1.125 math fraction 1/8. So you should be able to do this in your head. Sometimes we're gonna, but you can check when there's numbers on your calculator. So obviously, like when we get here, like to x's, you can't really check. But I'll show you a way that you can check. But you want to learn the rule. But when it's just a number, you can sort of check and see if you're on the right track. Okay, so here we have something similar. We have a negative exponent, so we're gonna do 1 over x to the 5th, right? So whatever was on top is now on the bottom. A way to check this in your calculator if you're not sure is just pick a number. So let's pick 3.2, right? So 3.2 to the power of negative 5. We check if that's the same as 1 divided by 3.2 to the power of 5. And so it's the same. So you can check by putting in your own number. Or you could just learn the rule and be confident in that. Okay. 3 to the negative 2. Very similar to the other problems. 1 over 3 squared, or 1 over 9. You could check that one in your calculator. And then this one's a little trickier. So this one, right, our base is y, and our power is negative 4. So the only thing that's moving to the bottom is this guy. This 2 still stays on the numerator. So we're going to have, you could think of it like 2 times 1 over y to the 4th. Or you could have been like the 2 is in the top still, y to the 4th is in the bottom. But this is the answer. Let me show you the difference, right? If it was parentheses 2y to the negative 4th, then what would happen? It would be 1 over 2y to the 4th. Or you could do 1 over 16y 4th. So see how the parentheses changed a lot, right? This one didn't have a parentheses, so it was just this guy moving to the bottom, or moving to the other side of the fraction bar. But if there was a whole parentheses, then you would apply this negative 4 to the whole thing. So you just want to be really careful, because I saw a lot of mistakes like that in the previous unit. And it makes sense because it is confusing. Alright, simplify, then rewrite using positive exponents. So if you want to pause and try it and check back, I'd recommend that. That's the best way for you to learn, right? Is to like do something and check and see if you got it right rather than just copying. But you can also follow along, right? Okay, so the way that I like to do this is to think about the ones that are moving, right? So this guy's moving because it's a negative exponent. So everything else is going to stay on top. We have 2x squared z squared, and then this is the only one that moves to the bottom. Alright, so let's try another one. I'm going to use a highlighter. We're going to do green top, pink bottom. Okay, so, right, we already have a fraction here, so this is on top. This is on top because it's positive. And then this is negative on the bottom. There's a negative, negative. Hopefully you're not colorblind, because sometimes red and blue look the same. Okay, so we have all our things on top. 1 times b to the 5th, all over 4 times a squared c to the 3rd. And then we're just going to simplify it. We don't want to write the 1 there. Sometimes I see that. It's not really simplified, so we're just going to simplify it. Okay. This next one looks a little trickier, but we just have to follow our order of operations. So remember, we have GEMDAS or PEMDAS. Right here, we have an exponent, so we're going to multiply. So we do 3 squared. Remember, this goes to all of it because it's in the parentheses, right? So 3 squared, y to the negative 6, sorry, x to the negative 6, y to the 0, because 0 times 2 is still 0. And now we can simplify. So this goes to 1. This is going to go to the bottom. And the other one stays on top. Right? So we have 3 squared over x to the 6th. And then we can just simplify that as 9 over x to the 6th. Okay, last one on this paper, but there's still more in the back. We're timesing, right? So if we have GEMDAS, we're going to add. So let's put these in parentheses to make it a little easier to see, because it looks sort of tricky, right? So we are multiplying. So these multiply like normal. So always don't forget that the coefficients, the numbers in front of the variables, they're going to multiply like normal. So 2 times 3 is 6. And then we have m. We're going to do 4 minus 3 because we're adding them. And then we have n to the 1 minus, well, here, let me write. So we're adding, right, just to make it more clear. So we have 4 plus negative 3, n to the 1 plus negative 5, right? So this is our multiplying. And now we can go through and do it. So we have 6m to the 1, n to the negative 4. Now we know that this guy's going to move to the bottom. So we have 6m. I'm going to just simplify that, not have the 1, n to the 4. So that's the way to do it, using the multiplication first and then using your negative exponents. I'm going to go over here and do another way. And you just have to think about which way you like back. You like best. Okay, so what I'm going to do here is I'm going to instantly notice that these go to the bottom. So I'm going to write 2m to the 4th n times 3. So I probably should have done that first, but that's okay. And then we have m to the 3rd, n to the 5th. And now I can cancel like we did before. So there's 3 here. So I know there's only 1 left. And then I took away 1 from the top, so there's only 4. So I'm left with 6m n to the 4th. Let me break this down a little further. So right, if I had 2, 1, 2, 3, 4, and then an n, and then a 3, and then I had 1, 2, 3, 1, 2, 3, 4, 5, right? And so you should be able to do it just algebraically, but if you need to write it all out to help you see, right, cancel, 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 cancel. Oops, those aren't the same thing, right? And then cancel that n. So we're left with the 6 on top with an m, and then the 4 n's on the bottom. So there's a few ways you could do it, right? This one I moved the negative exponents first, and then I sort of like simplified. And this one I did the multiplication by adding the exponents together, and then I moved the negative exponents to the bottom, and then I simplified. Alright, back side. We got 3 more problems. We got this. Okay. Simplify, then rewrite using positive exponents. So I'm going to do both methods here. We have our GEMDAS. Oops, D-A-S. We subtract when it's a division problem, right? So here we have 4 divided by 2, which is just 2. We have x squared minus 5 because we're subtracting those. We have y to the negative 3 minus 2. And then we have z already to the, negative 4. It's already on the bottom. So if we were to simplify it, right, we have 2x to the negative 3, y to the negative 5, all over z to the 4. We need to move these guys down because they're negative. So we have just 2 on top all by himself, and then we're going to do it alphabetically. You don't have to, but it's like sort of the standard rule. X cubed, y to the 5th, z to the 4th. Right, so in this version, I did my subtracting exponents for division first. Over here, I'm going to do it again, but I'm gonna do the moving first, and then canceling. 4x squared, y to the negative 3, all over 2x to the 5th, y squared, z to the 4th. Okay, so for this one, I'm going to move the negatives first. So I have 4x squared over 2x to the 5th, y. So I'm moving 3 to the bottom, so this is going to be 5, z to the 4th. You could have done a step before that and put like y to the, I'll show you. Okay, so we could have had y squared, y third, z 4th, and then you see that you have to add those. So 4x squared, 2x to the 5th, y to the 5th, z to the 4th. Or you could have just skipped this step because you could tell right away that it would become y to the 5th. And now we're going to cancel. So we have 4xx, 2, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4. Right, so these are the only guys that cancel, and then this turns to a 2. And so then we're left with just 2 on top, and then our 3 x's, our 5 y's, and our 4 z's. Right, so Same thing, different steps. As long as you're being careful, right? And you can double check, right? You could do two methods and see if it comes out the same. But there's a few different ways to do it, which order you can do it. Okay. Problem over here. 2xy to the 7th to the 0th. Okay, so what you could do is you could use your exponents and multiply across. But what you want to notice is that this is a 0. It's around the whole entire thing. So this actually all just equals 1. Right? Let's say, do alternate universe, right? What if we had 2xy7 to the 0? If that was the case, then it would be, this whole thing would be 1, and it would be 2 times 1 equals 2. So, right, parentheses matter, but remember, whatever is raised into the power of 0 is going to be a 1. Okay, last one. Bring the pain, right? Let's add all of it together. Super complicated. Okay, so our first step is we're going to do exponents. So we're going to do, I'm just going to label our steps since this one's a little more complicated. So we have GEMDAS. We're going to do our exponents to multiply. So we're going to do 2 to the 3rd, x to the 3rd, y to the 12th, all times 3x to the negative 3, y squared, all over 4x to the negative 3, y to the 0. Alright, the second thing I'm going to do is simplify. So 2 to the 3rd is 8, x 3rd, y 12, 3. So if you look here, these actually cancel. So you actually don't need to move them back and forth. So in this version, I'm just going to cancel them. And this I'm going to turn into a 1. So we have 3y squared on top, all over 4. And then I'm going to keep simplifying. So this cancels to 2. 2 times 3 is 6, x cubed, y, and then we add them together. Well, let's keep them separate and make that another step. GEMDAS. So we multiply, we add 6x cubed y to the 14. So this one was nice because there was negatives on both sides and they just ended up canceling. Ooh. But if you wanted to, you could have moved them over, right? So let's go to an alternate, right? Second step. Negative exponents. You could have had 2 to the 3, x to the 3, y to the 12, and then you could have had 3y squared, and then you brought this guy down, so x3, and then on the bottom we have 4, x to the negative 3, y to the 0, which turns into 1, and then we could have moved this guy to the other side, right? So we haven't seen that really. When we have a negative exponent on the bottom, it flips to the top, right? Neg x denom to numerator, right? So 2, 3, x3, y 12, 3y squared over x3, 4, and then the x3 goes back up here, this one, right? And then that's it. And then we'd simplify it all out, right? Like, okay, now we can see this cancels, you know, this cancels, and then we simplify it and get the same thing. So again, there's a few ways to do it. Once you practice them a lot, you'll notice that you can skip some steps, or you'll be able to like do them in your head. And then let's real quick, let's do a check, a calculator check, right? Calc check. We're gonna just pick random numbers. We're gonna pick x equals 1, y equals 3. Okay, so we have 2 times 1 times 3 to the power of 4 to the power of 3 times 3 times 1 to the power of negative 3 times 3 to the power of 2, all divided by 4 times 1 to the power of negative 3 times 3 to the power of 0. So we get this huge number, right? And then let's try over here. 6 times 1 to the power of 3 times 3 to the power of 14. And we got the same number. So you can always do that. You can always plug in random variables. When you're trying to do variables, you can plug in a random one and see if it works. So I would suggest going through the practice problems, looking at the odds, and making sure you got this, because this stuff's really important and it's going to come back a lot.